Okay, this is a chi-squared test of independence, and I'm Mr. Spensei, the stats sensei, and I'm glad you're joining us. To determine whether or not men with a combination of childhood abuse and a certain abnormal gene are more likely to commit violent crimes, a study is run on a simple random sample of 575 males in the 25 to 35 age group. The data are summarized in the following table. Okay, so we have the data in the table, and the question is, and we're only going to do part A, we're not going to look at part B and C. The part A is there evidence of a relationship between the four categories and behavior? So is there a relationship? They want to know if they're independent, all right? Notice we have a single sample. The fact that we have a single sample and we have multiple categories lets me know our multiple variables. I know I'm working with a chi-square test of independence. And they also give me the keyword relationship. And so that also is indicative that we're working with a test of independence. All right. So they're looking for the relationship. So the four categories of behavior the four categories in behavior are independent. So this are independent of behavior, or the four categories in behavior are not independent. Please remember, when we say that they are independent, we're saying they're not associated. We're saying they're not related. The four categories are not independent, then we're saying they are associated or are related. Random sample, they told us it was, that was given. Our expected values, we don't need to calculate those in a moment. We need to worry about the N is less than 10%. And on the N is less than 10% category, they sampled 575 males. So 575 divided by 0.10 equals 5,750. And there are more than 5,000 males in the 25 to 35 category, and we need to write that out. But to save time, I'm not going to write that down since it's not already typed. So we need to check our expected values. How do I do that? Well, normally they will give us space in the table to write that down. When I look at the table, I have 1, 2 rows and 1, 2, 3, 4 columns. So this is going to be a 2x4 matrix. And I'm going to go second. And then I'm going to go to where it says matrix, which right here at the x -1. Over the word edit, press enter, and 2x4. All right, so I need to start inputting my data, and I just overwrite what I already have. So 48, enter, 21, enter, 32, enter, and 26, enter. Then I have 201, enter, 79, enter, 118, enter, and 50, enter. Once I have that in there, I'm going to second quit. And I know this seems odd, but we're going to go ahead and run the test. So stat test, we're going to run a chi-square test, which is letter C. And we end up getting a chi-squared value of 7.75 and a p-value of 0.051. We're going to write that down because we're going to need that here in a little bit. So our chi-squared is 7.75. We don't need it yet, but we will. Our p-value is 0.0514. What we need is our expected values. So here's what we need to go. We need to go back to our matrix. So second matrix. We're going to go over to edit, and we're going to drop down, and now we see that in B we have a 2x4. We press enter, and now we have our expected values, and you need to write every one of those down. All right. Technically, it's 249 times 127 divided by 575 gives me this. 249 times 448 divided by this will give me that. So that's what we do. All right. We've already said our degrees of freedom were 3. All right, and well, actually we didn't, but the way we did that was we had 2 rows minus 1 times the 4 columns minus 1. So we end up with 1 times 3 is 3, so our degrees of freedom is 3. And then we're just plugging in our table values, 48 minus this squared divided by the 54.997. And we'll do that for all of them. And since we can bookend it, we always just have the first one and the last one, which is 48 minus 54.997 squared divided by 54.997. And then 50 minus 59.214 squared divided by 59.214. And so it'll look something like this. We've already seen that our chi-squared value was 7.75 and we had a p-value of 0.0514. That happens to be greater than alpha. So we failed to reject the null. Our p-value is 0.0514. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that the 4 categories in behavior are not independent. All right. So our conclusion is based on our study, we have to believe that the 4 categories of behavior are not associated and that they are independent. All right. So because we failed to reject. All right. Thanks for watching. Hope to see you on the next one.